WGAN Forum Podcast number 161. Tuesday, December 13th, 2022.
This WGAN Forum podcast is sponsored by the We Get Around Network Forum, your source for Matterport and related 3D and 360 platforms, cameras, and third-party add-ons. Visit WGANforum.com.
This WGAN Forum podcast is sponsored by the We Get Around Network Forum, your source for Matterport and related 3D and 360 platforms, cameras, and third-party add-ons. Visit WGANforum.com. The following article first appeared on the Robotic Imaging Blog on March 18, 2022. It is reprinted with the permission of Robotic Imaging. Robotic Imaging, LODs in BIM explained. What is LOD? LOD or Level of Development is a defined industry standard that helps project leaders, architects, engineers, and other project leaders describe the state and completion of different design phases. Essentially, it is a standardized way of understanding what information the BIM model should have during the completion of each phase of a project. The levels, as created by the American Institute of Architects, include 1. LOD 100, Concept Design. 2. LOD 200, Approximate Geometry. 3. LOD 300, Precise Geometry. 4. LOD 350, Greater Detail and Construction Documentation. 5. LOD 400, Fabrication and Assembly. 6. LOD 500, As-Built Model. Level of Development versus Level of Detail. Both level of development and level of detail use the abbreviation LOD, but both mean different things. Level of development shows the level of thought put into a project's geometry, specifications, and other information. It also shows the levels of dependence team members currently have on the information in the model. On the other hand, the level of detail is how much of that data is currently within the model element. Essentially, the level of development is the reliability of the output, and the level of detail is the comprehensiveness of the input of information. Suggested reading: if you want to learn more about BIM terminology, check out Robotic Imaging Blog. Levels of Development. The American Institute of Architects created LOD in 2009 to set universal design expectations. Universal expectations are necessary so collaborators understand the level of detail needed to move on to the project's next phase. There are 6 different levels of development, as defined by the American Institute of Architects. They are: LOD 100, Concept Design. At LOD 100, the project, deliverable, or element model still consists of 2D properties. This is the most basic of all development levels. Sometimes, LOD 100 consists of a hand-made sketch. However, it is ideal to keep in mind that data will have to be transferred to a BIM design tool in the future. LOD 200, Approximate Geometry. In this phase, the concept design and any relevant data transform into a model that can create construction documents. After this phase, the model will have basic object data. This includes the object's size, quantity, location, and systematic relationships. LOD 300, Precise Geometry. In this phase, the design begins to look like the final product. 3D elements are introduced, like object dimensions, connections, and capacities. Once this phase is completed, all objects have accurate information housed inside the model. LOD 350, Greater Detail and Construction Documentation. In this phase, all the information about the element is included in the model. This consists of the element's relationship and connections with all other objects. LOD 400, Fabrication and Assembly. At LOD 400, elements are completed, with details about fabrication and assembly. Once this phase is complete, the model has enough detail to accurately fabricate all components of the structure. LOD 500, As-Built Models. Whereas other LOD levels increase based on the added geometric or non-graphic detail, LOD 500 shows the element as-built. It is a verified field representation of the structure, including its actual size, shape, quantity, location, and orientation. Closing. Each LOD often requires distinct modeling and different tools to create those models. No matter the stage you are at, robotic imaging can help provide the data and models you require. Reach out to Robotic Imaging to find out more. Source: Robotic Imaging Blog.